Hello everyone. Our question for today is the following integral. The ln of square root of x plus the square root of x plus 1. I will start by letting u equal to the square root of x plus the square root of x plus 1. And this is what we get for du. Let us find a common denominator. And this is what we get. But we can replace the top by u. Then isolate dx. And this is what we get. But of course, this is not that helpful because we have x and u in the same expression, and we need to end up with an expression that only contains u. So we have to do something in order to get rid of the x. To do that, let us come back to the key relation between u and x. We move the square root of x to the other side, and then we square both sides. These x's cancel out. We then isolate the square root of x, which means I have to divide both sides by 2u. But first of all, can we divide by u? Are we sure that u cannot attain the value 0? Yes, of course. Because u is equal to the square root of x plus the square root of x plus 1. U is the square root of x, which is non-negative, plus the square root of x plus 1 that is greater or equal to 1. So u is greater or equal to 1, which means u cannot be 0, and thus we can safely divide by u. So this is what we get for the square root of x. We square both sides, and we finally get an expression for x. Let us now explore what x plus 1 is in terms of u. We start with the following. X plus 1 is equal to this expression plus 1. We expand. These twos cancel out, as well as the u's, and we get this. We now add negative half with 1. Then we again write 1 over 2 as this expression, 2 times u over 2 times 1 over 2u. And what is that? That is a perfect square. And this is really beautiful. We got x plus 1 is equal to u over 2 plus 1 over 2u all squared. We now come back to this expression, dx in terms of du, and we are now able to express dx in terms of u only. We start by replacing x and x plus 1 by their corresponding u expressions. That's what we get. Let us put both factors under one square, and then a difference of two squares pops up. So it gives us this, and that's what we get for dx. But we've seen that u is greater or equal to 1. We still need to investigate whether we can remove the absolute value or not. Let's do that. If we find a common denominator of this expression, we get u to the 4 minus 1 at the top, which is written as the product of these factors. We said that u is greater or equal to 1, so u minus 1 is greater or equal to 0. U plus 1 is obviously greater than 0, and u squared plus 1 as well, similarly to u squared. This means that the expression inside is non-negative, and we can safely remove the absolute value. We still need to simplify this, and we finally get this expression for dx. Now we can go back to the integral and solve it. The integral becomes this, which splits up into the difference of the following two integrals, and both can be easily approached using integration by parts. So for the first integral, we let t equal to the ln of u, and ds equal to u du. So dt is equal to 1 over u du, and s equals to u squared over 2. We apply the integration by parts formula, and we end up with this, and that's the final answer for the first integral. But of course, we eventually have to multiply the answer by half. We do the same thing for the second integral, and we get the following. And this is the answer for the second integral. Thus, the main integral becomes this expression. We still have to bring u back to x, and this is the final answer. Thanks for watching. I hope you enjoyed the video, and see you soon.